Hello, everyone. Thank you for coming to this session. I really appreciate you taking the time to stand in that line and to stand in another line, but thank you for coming. This is the state of data engineering, and we're going to be talking about 3 paths to success and failure. But first, I want this talk to be offensive to you. I want it to be so offensive to every single one of you that you change something. Because I've done a lot of talks, and people will come up to me and say, hey, I heard you speak, but I didn't do anything. I want you to be the one that does something. So I'm going to be so offensive to you that you're going to do something. Hopefully it's the thing that I want you to do. And it's because we sucked. We've sucked for a long time. You wouldn't think about it because we're here at a data conference and everybody's here. Do we suck? I think so. I think we're generally not doing what we should be doing. So let's talk about this. We have 3 paths. We have 3 different types of people that are out there that are being put forward as, here are the types of people that we can rely on. So that first type, that's a data warehousing. How many of you are data warehousing people? SQL focused? Okay, a few of you? Okay. Prepare to be very offended because I'm going to be offending you. I want you to change. You. Yes, you. Okay? How many data scientists do we have here? All of you. I want you to change too because you're thinking about, oh, I'm going to do data engineering. You are the promise of the 2010s, the mid-2010s, but you need to change as well. How many data engineers do we have in here? Oh, good. Okay, I will still offend you because you may not be the type of data engineer that we'll need. So prepare to be offended for that as well. So here's our longest lived path, the data warehousing team. I call them the no team. Do you know why I call them the no team? Because if you ever want to be called or told no, you go to the data warehousing team. I need this report. I need some help. Am I right? You were supposed to say no because you're the no team. Okay, so here we have the no team. We have the no team validated. If you ever want to be told no about something data related, you go there. And here's the problem. The data warehousing team, they weren't skilled enough. They weren't technically skilled enough. They couldn't do this. And when they could do it, they were so mired in legacy problems, so many problems that they could never do anything. So they had low business value production. Does that sound like a good recipe for success? This team is the one that's going to get us business value, right? Right? Guess not. So, I have a question for you. How many different data warehousing teams have you seen at a new company started in the past 5 years? Raise your hand if you've seen one in the past 5 years. I got one hand, okay. Past 10 years. We got 2 hands, 10 years. Do I hear 15 years, 15 years, 20 years? Okay. Okay, now, why am I asking that question? Why am I asking if we haven't had data warehouse teams created in the past 15 years at new companies? Do you know why? Because they're low value producing. The companies, these new companies, they looked at what was happening and they said, oh, I'm not even going to bother. This is a big problem. Because if you look at the past, if you're a data scientist, that can help predict the future. Our future, what we're looking forward to in the future is in 10 years, data engineering team saying, oh, who's a data engineer? And nobody raises their hand. Nobody's going to be here because we're not creating very much value. This is what I'm trying to get you to change and trying to not see happen. Okay? We have the second path. So there is a lot of data scientists over here. You are the mistook or the mistaken team. You were mistaken for people who could do data engineering and data science. Turns out you can only do data science. You can't do data engineering. So you sit there and you wait for the data engineers to do something. Right? I see some sheepish shrugs of shoulders, which means yes. Okay, yes. Yeah, they were told. How many of you were data scientists? You were told, oh, you're going to be able to do this data thing. Yes, okay. Lots of sheepish yes. And it's because, we'll find out later on, hey, it isn't something you just came up with this. You were told by people that this is what you could do. So you have all these failed and unproductive AI projects. There's a lot of problems. And probably the biggest thing for data science projects is, here, let's ask this. How many of you actually have something in production who is a data scientist? Okay, you don't have to be sheepish this time because you actually have something in production because you're the only one who raised your hand. You should be like, yes, I am the only one. So this is pretty bad. This is really, really bad if we have, in this group of people, only one person with something in production, because there's a lot of money sitting in this room, right? All of our salaries, all of our this, all of our that. And here, we should just be talking to him. So how did you get that in production? Okay, so, and then we have this issue of, so all the data scientists who were actually bad at data, they're going to become data engineers right now. How many of you are data scientists who are trying to make the switch? You don't have to be sheepish this time. There's got to, okay, I got one hand. No other hands? Okay. Usually there's a lot more hands up because they're trying to make this search and replace. I'm going to search and replace myself. I am going to become a data engineer because I like data. I'm the most technical data engineer on my team, or technical data scientist. I can do this data engineering thing, right? Right? Yes? He says yes. Okay. The one guy who's done it, he says yes. Okay. Then we have our third path. Except we have data engineers, but we're the confused team. So what exactly are we? What's a data engineer? I don't know, because there's so many different definitions out there. What do they do? Should they have a bunch of nuanced variations? Should there be an analytics engineer? Should there be an ETL engineer? Should there be, how many of you are analytics engineers? Okay, prepare to be offended. Okay? Because you're going to need more skills. Okay? So, just how technical should they be? That's been one of our biggest issues, is telling each other or figuring out how technical should I just be a SQL jockey? And that's a problem. So, within this room, there's going to be all sorts of different answers to these questions. And we can only really answer these questions by looking at what is difficult about data engineering. I've spent a non-trivial amount of time thinking about this, and it's not in meme form. I really think that we are different than other fields. Different enough where we can't just say we have a specialization. We have to go deeper into that specialization. So, scalable systems. Part of what's difficult about our job is we have to create scalable systems. How many of you create scalable systems? Lots of you. Okay. This is a very difficult thing. Do you know why? Because we have to use distributed systems. And these distributed systems, no matter what vendors say about distributed systems, they're hard. They're really hard because distributed systems are inherently difficult to understand, difficult to architect, difficult to program, or we may even have to multi-thread them. Maybe we have to do both. Both of these things are advanced concepts. They're difficult concepts to actually do. Complex code. I was thinking about this one day when I was writing a hello world. Our hello worlds in data engineering look like advanced examples in other designs. We can't just say print hello world. We have to do this and we have to do that. We have to have 20 lines of boilerplate code in order to just do something like simple as a word count. And when we get into something advanced, it looks more like a PhD thesis, where when let's say you join at a new company and they're trying to explain, the explanation doesn't take an hour, it takes days, it takes weeks, because we're that complex. We're creating incredibly complex code. And then to top it off, we have complex workflows. We have incredibly nuanced processes. We have to take data from here, here, and here, do this, this, and this. We have to do a lot of these things. Oh, and by the way, all of that has to be completely repeatable, completely reusable, fault tolerant, difficult, right? Okay. Oh, and then there's the many different technologies. How many of you have been to a conference lately? I don't know, let's call it Big Data London, and seen a lot of different technologies? And you have to maintain some amount of knowledge about this? Just maintaining this knowledge is really difficult because we have to take all these different technologies. I get to stand here and look at a lot of them and say, okay, this technology is not an island unto itself. This technology, I see Databricks has to work with this other one and work with this other one. And getting these things to integrate well with each other is a whole difficulty unto itself. And then we're the business interface. How many of you had to deal with a part of the business that has never dealt with an IT product before? A lot of hands went up this time. And is that a lot of fun? He shook his head, yes. It was a lot of fun because these people have no idea what it is to create these systems, what it is to do a system. They just kind of expect it to work. You press a button. It's like an Excel macro, right? You just type in this and it's easy. So having to be the ones that interface with these different parts of the business, it's really difficult because you have to educate them, you have to push them. It's not an easy thing to do. So, and then to top it all off, we have to have in-depth knowledge. Let's do another round of questions. How many of you know the ins and outs of 5 different technologies? Raise your hand. Just one person? Okay, you and I will talk later because I was expecting more. But let me insult all of you. You need to know more, okay? You're at the right place. Go around to these vendors. Don't just get a sales pitch. Ask them what their technology is used for. Ask them when you should use it. Okay, this is important because if you're doing a data engineering project, it actually may be significantly easier to use one of these technologies than another. And if you don't know this, then guess what? You may be doing something that is just entirely not possible, not as easy. So go around, learn. This is a great place to learn. Okay, so yes, but, okay, Jesse, I heard you, but I have my own ideas on this. Okay, let's go through some of those ideas. I'm a data warehouse engineer and I've never had to program, never had to create. How many of you are thinking this right now? Nobody? Okay, good, because I see that on Reddit quite a bit. I've never had to do this, so this doesn't exist. Well, you just haven't hit that yet, quite honestly, quite frankly. And so you will. You will eventually hit this, or quite frankly, what usually happens is it hits you, you just didn't realize it. There was the step function level of difficulty. When I say a step function, instead of it going up gracefully, it goes up like that. You hit this wall and you may not have known it, and you left a bunch of technical debt there because you didn't know this. Or how many of you are the most technical data scientist on your team? And I know this data thing. Yes? You are the most technical and you've got this all down? Okay. That's the look of a man who says, yes, I've got this down and I know where my technical debt and all those bodies are buried. All right, you and I will talk afterwards then. Okay, so here's the problem. The most technical data scientist is still not a data engineer because there's a different level. There's a whole other level that's there of technical difficulties that we just went through. My vendor told me this will be easy. How many of you ever heard this before? A lot more hands up now. I've been told this is easy. And did it turn out to be easy? Okay. Raise your hand if it was easy. Raise your hand. Okay. Yeah, your vendors will tell you it's easy. It's not easy. Data engineering is inherently not easy. Or how many of you have been told by a data influencer that this is easy? Just need to learn one technology. Learn one technology, okay? You just learn that one technology and you can make a 6-figure income. 100,000 pounds, 200,000 pounds. You just know that one technology. This isn't true either because we know the ground truth. at least I do. I've consulted, I've worked with companies. All of these promises that are made to you are just not feasible because we know the truth. We are able to go through and see and say, oh, actually, I know this. I've went through this. I've seen this. So let me offer my definitions to those questions that I asked before. So now that we've identified and we've went through and said, okay, here is what's difficult about data engineering, I'm going to share my responses to all those 4 questions. And I'm hoping we won't be the confused team anymore. So my definition of a data engineer is a software engineer who has specialized their skills in data. How many of you agree with me? Okay, a lot of hands. How many of you disagree with me? How many of you are offended right now? Okay, nobody's offended yet. I'm not trying hard enough. What am I missing? Who am I not offending? Okay, so this is really important. I saw this gentleman shake his head yes when I said software engineer. It's really important that as we get into really complex systems, we create really complex code. You can't just do this in SQL. Some things you can do within SQL. Completely fine to do those. Do those things that you can do in SQL, but those things that you have to do in code, if you try to do that in SQL, it won't work. It's completely unmaintainable. We have to be software engineers as well. We have to be able to do both. By being able to do both, we can pick and choose our tools, choose the right tool for the right job there. So what should a data engineer do? I believe that a data engineer, our definition, our job function that should be on every single one of our resumes is to create maintainable, usable, valuable data products. And there's an importance on this focus on a data product because a data product is inherently usable. Our data product is something that the business uses on a daily basis. It is the thing that we do. It is the most important thing that we can do. But there's some other parts to this, some other qualifiers. Maintainable. How many of you would say that your code is maintainable? Your data product is maintainable? Yes? I got a few people saying yes, okay. And that maintainability is on several different fronts. It's code, it's architecture. If you make a change, does something break it? If new data comes in, does it break it? These are a bunch of things that we have to do with our data products. Is it usable? Can somebody from the business actually access it? If I were to talk to the business user of your data product and say, if this went away tomorrow, this is a good question to ask. If your data product went away tomorrow, would anybody ask? Would anybody care? Think about it for a second. This is how you know if you're creating something that's valuable, something that's usable, is if it goes away tomorrow, do they care? If they care, you've created something valuable. Make sense? Ask that. Think about that, truly, please. So who is on a data engineering team? The data engineering team should be predominantly made up of data engineers. That was why I gave that definition of data engineer before. Your data engineering team will be predominantly made up of this. They're going to be predominantly made up of these data engineers. That isn't to say that there may be some other titles. Maybe there's an analytics engineer. Maybe there's somebody who's a SQL developer. But if your entire data engineering team is made up of SQL developers, you're going to have a bad time because it doesn't allow you to do those other things that I was talking about. Okay, so how technical should they be? They should be really technical. They should be deeply technical. And this is part of, given the hands raised of what we were seeing, what I saw, this is the way that you should all be offended into doing something, is that you should be knowledgeable about every single one of the technologies that you're using, as well as other possibilities. And this is a good place to do that. So you should be deeply understanding. Let's say you have Kafka. How many of you know how Kafka works? How many of you deeply know how Kafka works? How many of you deeply know the manifestations of transactions? If you're using transactions, do you know how transactions break in Kafka? Do you know the trade-offs of it? Do you know this? Do you know that? These are the sorts of nuances that are really important that we need to do. And then to add on to that, we need to learn about other related technologies so that we can actually go through and understand, oh, maybe Kafka's great for this, but it's not great for that. Because if we just follow the vendors, what the vendors tell us, they'll say, use Kafka for everything. But I could tell that that hits you like this. Did that happen one time to you? Yes. Yeah, it was Kafka. No. Yeah. Yeah. Somebody. I know somebody. I won't say who. Got told use Kafka for everything, and they tried it. So, this is why we need data engineers in the room. Data engineers who understand this, because they need to ask some of these hard questions. They need to understand these things so that you don't use the technologies the wrong way. So let's revisit our 3 different paths. So we have our data warehousing. The problem with data warehousing is that there's no programming. We need programming. It's absolutely important, absolutely critical to have programmers. We can't get that level of code without this. They're SQL only, and that's a big problem. You can argue all you want with me about whether SQL is code. I argue it isn't. But the problem with SQL is you can't get that complex. You can't get that complex. It just is not maintainable. And the lack of distributed systems is a whole other problem. You need to have those distributed systems. Okay, data scientists. Here's the problems. You're mediocre at best programmers. And I say this with all love in my heart for all you data scientists. Your code sucks. Your design sucks. You don't do any best practices. Please learn how to program. Programming is not writing a bunch of syntax. Programming is making code that is maintainable, usable, so that the next person that takes your code doesn't want to kill themselves, okay? How many of you have inherited a data scientist code? I've got a few hands up. Okay, you, sir. Was that fun? Yes? You enjoyed every minute of it? Every minute, okay. So there's a man, so when they take him into the loony bin, then you know why. It was the data scientist code. Okay, the other problem is the minimal technical understanding. They just don't understand these technologies enough. They went maybe to a boot camp. Maybe they went to a data science course. Out of curiosity, those of you who are data scientists, how many of you went to 2 courses or more of computer science? Okay, just have one person? Okay, that's the first time I asked that question. That was how I understood. You'll get maybe 1, maybe 2. And you can't learn to program that way. You can't learn to do software engineering that way. So we have our data engineers. This is what our data engineers need to be. They need to have the advanced programming skills. They need to know how to program. They need to be software engineers. Data engineering teams generally skewed to senior people. They need to have a background in distributed systems because they need to understand how one system talks to another, as well as this deep technical and business understanding. We need to be able to be the ones that translate something that a business user who doesn't really know how to talk, we have to translate that into something technical, something very complex that works. Make sense? Okay, so how many of you are God, I blanked on the word. How many of you are so mad that you're going to make a change? I hope so. No? A few of you? Okay. No? Nobody's going to make a change? I hope you are. He's going to make a change. Okay. Okay, good. So here are the changes you need to make. You need to get the right people. So those right people are the right data engineers. We need to get the right people on the right teams. If you have teams that aren't made up of these people and you're looking at your data project and wondering why that project is going nowhere, more than likely it's one of these 3 things or all 3 of these things at once. And then focus on creating the right data products. The right data products is one that's usable, one that's maintainable, one that if the business says, if it were to go away tomorrow, that the business would actually miss it. They would say, where is that data product? I need that, I want that. So with that, thank you. I hope you've been duly criticized. let's open it up to questions and hopefully criticism from me.
A very quick one. You never mentioned the magic word AI. How does that fit in your vision, especially for the future?
So in a previous talk, I would talk about it, and it's the issue with AI for us as data engineers is it makes us maybe 10 to 20% more productive writing code, but it's not the promise of 200%, 300% improvements. So I don't see it as helping us. I see it as helping us on the boilerplate. So getting us away from writing more boilerplate code, but the AI, I just don't see it helping us writing code. That said, then there's the whole systems creation, the whole systems usage. That's when I do see some interesting things. I bet we're both misusing and underutilizing AI in many ways, where we can now process unstructured data in a way that we could never before. So that's basically what I see there. Another question.
I tried to build a data engineer team as you explained, but the business and management doesn't agree, and they tend to propose more simple systems that automatically done things. What do you think about this?
So to repeat his question, management is saying, hey, they've bought into some marketing. So tell them that. You've bought into some marketing that says, if you use our tool, you don't need qualified people. And that's never worked because you still need qualified people. The benefit to these tools is that you can have your qualified people focus on things that are interesting, focus on things that are part of your business. So in other talks, the advice I give people is focus on the things that only you can do in your business, the things that a smart person can do. So what I would tell your management is say, yes, that will help us to get from point A to B faster, but it won't allow us to get to point D, to point E, to point F, because we're missing the people to do those things. And that is where, if the bit of advice I'll give all of you is to focus on the things that only you can do in your business. Because all of these vendors, they're general purpose systems. They can get data from point A to point B, they can process the data, but only a smart person can do the thing that your business needs. Make sense? Okay, I think we have time for one last question. And it has to be a quick one. No? Okay. Thank you so much, everybody. Have a great show. Thank you.